Hello. These are the review problems from yesterday. The first one, list all the possible outcomes for each problem situation. Complete the probability model using all the possible outcomes. So if we have a spinner that has two parts, one side is blue and the other side is white. Okay. What is the probability that spinning the spinner three times will result in only one blue result? List all the possible outcomes for the three spins. Complete the probability model. All right. So if my first spin is blue, my second spin could be white, and then my third spin could be blue. My first spin is blue, my second could be blue, and then my third could be white. If my first spin is blue, my second spin is white, my third could be white. If my first spin is blue, my second spin is blue, my third spin could be blue. Okay, that should be all of the possible outcomes with blue as the first spin. If white is the first spin, and then I do white again, and then I do blue. If white's the first spin, blue, and then white. If white's the first spin, white's the second spin, and white's the third spin. If white's the first spin, then blue, and then blue. And then it would be 2 options times 2 times 2. So there's 8 options, so I know I have the right number of options. The next thing I need to do is I need to fill in the probability model. And I'll have an outcome. Slide that over a little bit, sorry. I'll have my outcome. And then I'll have my probability. And so for me to have 0 blue, well, that only occurred the one time here, so it'd be 1 out of 8. To have 1 blue, that would have occurred once, twice, 3 times. So it'd be 3 out of 8. To have 2 blues turn up, I would have 1, 2, 3 times. So 3 out of 8. And then all 3 blues would occur 1 out of 8 times. And then to double check, 1/8 plus 3/8 plus 3/8 plus 1/8 is going to be 8/8, or all of my possibilities. So that is my answer for the first review problem. All right, review problem number 2. A bag contains a purple stone, a yellow stone, and an orange stone. A stone is randomly chosen from the bag. The stone's color is recorded, and the stone is replaced in the bag. If you choose a stone from the bag 2 times, what is the probability that only one of the chosen stones is purple? List all the possible outcomes of choosing 2 stones. Complete the probability model. Okay. So if the first one is purple, second one could be purple. The first one's purple, the second one could be yellow. The first one's purple, the second one could be orange. If the first one is yellow, the second one could be purple. First one's yellow, second one could be yellow. First one's yellow, the second one could be orange. Or the first one's orange, the second could be purple. First one's orange, the second could be yellow. The first one's orange, the second could be orange. Okay. Now I gotta create a probability model. So again, I have the outcome, and then I have the probability. And with that, having 0 purples, see here, 3 times 2 choosings is 3. Interesting. Okay, let's see here. 0 purples would be 1, 2, 3, 4. So it'd be 4 out of 9. There's 3 options on the first pick. There's 3 options on the second pick. So that's a total of 9 outcomes, and we have 9 outcomes there. Having 1 purple show up would be 1, 2, 3, 4, 4 out of 9. And then having 2 purples show up would be 1 out of 9. Again, 4 ninths plus 4 ninths plus 1 ninth is going to be 9 ninths, which gives me all of the possibilities. Sorry for the lag. It's so weird. Sometimes I have a huge lag in my videos when I'm recording. Sometimes I don't. Number 3, a spinner has 3 equal parts. 1 part is green, 1 part is orange, and 1 part is yellow. Okay. What is the probability that spinning the spinner 3 times will result in 0 orange results? Complete the tree diagram to determine all the possible outcomes of the 3 spins. Complete the probability model. Right? And so I have to do a tree diagram for this one. And so we're pretending that this first line here is the first spin. Then we'll go down a line for the second spin. And whenever I'm doing this, I want to make sure that I am giving myself a lot of room, actually. And so green, orange, yellow. And then I kind of want to go in the same order every time. Green, orange, yellow, green, orange, yellow. And then on my third spin, green, orange, yellow, 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 green, orange, yellow. Okay. Let's run off a little bit. That's okay. Let's slide it back. Okay. If there's 3 options each time and I spin it 3 times, I'll have a total of 27 outcomes. 3, 6, 9, 12, 15, 18, 21, 24, 27. So 3 times 3 to the 3rd power, 3 times 3 times 3, 27 outcomes. So now I can make my probability model. Of 0, 1, 2, or 3 oranges. And so now I just kind of have to go through. Maybe going and using a different color might help me. And so I'm looking for oranges. So I kind of go down the trees, the tree branches. Green, green, green. So that's 0. Green, green, orange. That's 1. Green, green, yellow. That's 0. Green, orange, green. That's 1. Green, orange, orange. That's 2. Green, orange, yellow. That's 1. Green, yellow, green. That's 0. Green, yellow, orange. That's 1. Green, yellow, yellow. That's 0. Orange, green, green is 1. Orange, green, orange is 2. Orange, green, yellow is 1. Orange, orange, green is 2. Orange, orange, orange is 3. Orange, orange, yellow is 2. Orange, yellow, green is 1. Orange, yellow, orange is 2. Orange, yellow, yellow is 1. Yellow, green, green is 0. Yellow, green, orange is 1. Yellow, green, yellow is 0. Yellow, orange, green is 1. Yellow, orange, orange is 2. Yellow, orange, yellow is 1. Yellow, yellow, green is 0. Yellow, yellow, orange is 1. Yellow, yellow, yellow is 0. Okay. Now I have the ones with 0 is 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 27. 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 27. 2 is 1, 2, 3, 4, 5, 6 out of 27. And all 3 is going to be 1 out of 27. And then I want to check my math here. 8 27ths plus 12 27ths is 20. Plus 6 27ths plus 1 27th is 27 27ths. So that should be all of my options. I want to make sure that my probability there adds up to 1. Okay, here's the fourth one. These first 4 probably took a long time, and then they should have gone a lot faster. A bag contains contains a red stone, a yellow stone, and a blue stone. The stone is randomly chosen from the bag. The stone's color is recorded and the stone is replaced in the bag. If you choose a stone from the bag 2 times, what is the probability that only one of the chosen stones is blue? Complete the tree diagram to determine all the possible outcomes of choosing 2 stones. Complete the probability model. This one's easier because it's only 2. So this is my first. I chose red. Then on my second one, I could have chosen red or yellow or blue. Red or yellow or blue. Red or yellow or blue. Okay. Okay. Again, I can kind of just double check red, 0, red, yellow, 0, 1, 0, 0, 1, 1, 1, 2. So there's 3 options. So we have 3 times 3 because there's 2 pullings, so it's 9 total. And so it would be 4 out of 9 is 0 blues. 4 out of 9 is 1 blue. 1 out of 9 is 2 blues. Okay. So we need to be able to list the outcomes, or we need to be able to make a tree diagram with the outcomes, and then we should be able to put them into a probability model, which is a table. Number 5. a coin is tossed one time, the probability that tossing the coin will result in heads is probability of heads. What is a complementary event? Complementary event is probability of tails. Because those two will add up to 1. That's the opposite of it. That was easier, hey? A 6-sided number cube is rolled. The probability that the result is less than 3 is probability less than 3. What is a complementary event? Complementary event would be probability is, let's see here, 3 or greater. And you could have worded that a little differently. We just need to make sure that we include 3 as part of our answers. So probability that it's equal or greater than 3. Okay, make sure you're including all of it. So I was at first tempted to say greater than 3, but that would not have included 3, and then the two probabilities would not have added up to 100%. Number 7, a letter between A and E is chosen. I don't like the wording there, but I'm pretty sure they include A, B, C, D, E. Okay. The probability that the result is a vowel is probability of the vowel. What is a complementary event? Well, that would be the probability of a consonant. I believe I've spelled it correctly. Yes. So those first 4 were long, and since then it kind of goes pretty quickly. So I know some people are saying that this seems like a lot, and it does seem like a lot, but then you got going and it was a lot quicker. All right, number 8's a little longer. Marbles are placed in 2 buckets. The first bucket contains 1 marble of each of the following colors: red, blue, and green. The second bucket contains 1 marble of each of the following colors: yellow, green, purple, and blue. Determine the possible outcomes for choosing 1 marble from each bucket. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so if I have all the first marbles down there here, then my second one could be yellow, green, purple, or blue. Yellow, green, purple, or blue. Yellow, green, purple, or blue. So there's, let's see here, there's 3 in the first and then 4 in the second. 3 times 4 is 12, and I have 12 different outcomes. And these are the outcomes. That's all you needed to do for this number. Number 9. What is the probability of choosing 2 unique colors? So that is 2 different colors. So if I look through this, 2 different, 2 different, 2 different, 2 different, 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 same, different, same, different, different. So I believe I have 10 out of 12, which I could write as 5/6 would be the probability of choosing 2 unique colors. That just means that both colors are different. They're not the same colors. Okay. Number 10. What is the probability of choosing green from the first bucket and green from the second bucket? So if I look here, since I listed all my possibilities, There's only one that has both greens. It's and. And is saying it's got to be both of them. It's not or. And so it would be 1 out of 12 for number 10. What is the probability of choosing blue from the first bucket and blue from the second bucket? Well, once again, there's only one where it's both, and the way I use the word and, so it's got to be both of them. And so it's 1 out of 12. It's this one right here. Okay. All right. Number 8, what is the probability of choosing red from the first bucket and yellow from the second bucket? Well, there's only one on here that's red from the first bucket and yellow from the second bucket. They use the word and so again, that's going to be 1 out of 12. Last but not least, what is the probability of choosing the same color from each bucket? So if I go through here, there's not red and red because there's no red in the second bucket. So none of them are the same here. There is a blue and blue, and then there is a green and green. So that is 2 out of 12, or 1/6, because that is a complementary event to choosing two unique colors, would be choosing two colors that are the same. And so those add up to a probability of 1. And so that's a complementary event. Those are your review problems from Tuesday. And so now you're going to complete just fewer review problems today.